I am Mrs. Cheryl Bradshaw, and today we will be looking at problem solving using multiplication. Our learning target is to solve multi-step word problems involving any combination of the 4 basic operations on whole numbers. But before we begin, I want to introduce you to a method for multiplying. It's called the unitary method. Now, the word unitary comes from the word unit, which is a single item. And in order to use this method, we have to find first the value of 1 unit, or a single thing, or a single quantity. And then we're going to use that value to calculate the number of quantities that we require. On the screen here, we have a glass of orange juice for $6. And our problem is, 1 drink costs $6. What would you pay for 5 drinks? Using the unitary method, since we know the cost of 1 unit, we can use the cost of that 1 unit and multiply it by the 5 units or the 5 drinks that we need, and we would have 6 multiplied by 5, which will give us 30. So here we see that the unitary method can be used to teach and to solve problems in multiplication. But we are also going to be using our problem-solving steps. The first step is to read and understand. So when we look at our problem, we are going to be asking the questions. What do I know? Just as you would ask it at home, what do you know? What do I have to find out? Then we are going to plan how we are going to solve the problem. In planning, we are going to identify the strategy that we are going to use. Then we are going to do whatever strategy we have chosen. And at every stage, we are going to document our steps. Finally, we are going to check to ensure that our problem is solved. If it's not solved, we will have to go back to the top and follow the steps and come down again. All during this lesson, we used some problem-solving strategies. And I want you to remember that you could use any of those strategies to solve your problems. You can create a diagram, which is the same as drawing a picture, because that diagram can help you to picture the problem and help you to find the solution. You can use the guess and check strategy. You can use a table or make a list. You can reason it logically. You can find a pattern, or you can even work backwards. Our first problem starts in the kitchen. And as I read it to you, you can read it at home. The mass of a bag of onions is 320 grams. It is 38 grams heavier than the mass of a bag of garlic. What is the mass of 7 identical bags of garlic? Is 320 grams. I'm putting G for short. We know that that G represents grams. And we also know that this bag of onions is heavier than the mass of a bag of garlic. So I'm going to draw a little bar diagram to show you that. So this is your bag of onions. And then this is your bag of garlic. And your onions is 38 grams heavier than your garlic. So in order to find out the mass of 1 unit of garlic, because garlic is shorter than onions, we are going to have to do a subtraction. So we have 320 subtract 38. So 292 grams. That's our garlic. What else do we know? What do we have to find out? We have to find out the mass for 7 identical bags of garlic. Now we have the mass for 1 unit of garlic. We can find the mass for 7 units. And we find the mass by multiplying 292 grams by 7. 292 multiplied by 7. 7 2s are 14, 9 7s are 63, 64. 7 2s are 14, and 6 is 20. 20 grams. The mass of the 7 bags of garlic is 2,044 grams. This is problem number 2, and the context is shopping for school supplies. I will read the problem while you follow at home or read along with me. Marla bought a book bag, 8 notebooks, and 1 dozen pencils. She paid $300 and received $2 in change. How much did the book bag cost? Here we have a book bag. There is no cost attached to it. There is a pencil. The cost of 1 pencil is $1.50. And a notebook, the cost of 1 notebook is $15. Let's try to understand what we have written here. We know that she bought 8 notebooks, so we'll write that on the board. She bought 8 notebooks. We also know that she bought 1 dozen pencils, and 1 dozen is 12, so we'll write 12 pencils. We also know that she bought a book bag, 1 book bag. We know that the 8 notebooks was $15 each. We know that the pencils cost $1.50 each. We do not know the cost of a book bag. We also know that she paid $300, and we also know that her change was $2. We have to find out how much did the book bag cost. Our first step is to work out the cost of the notebooks. In the next step, we're going to find out the cost of the pencils. We'll begin with these 2 steps. So our number sentence, we are going to write down our number sentence and we are going to solve. 8 notebooks at $15 each using the unitary method. 15 multiply by 8. 8 5s are 40. 8 1s are 8 and 4 is 12. So the notebooks cost $120. The pencils. We are going to multiply $1.50 by 12. Multiplying with our ones. 2 zeros are 0, 2 fives are 10. 2 ones are 2 and 1 is 3. Multiplying by our 110, we put our 0 for ones. 1 0 is 0. 1 5 is 5. 1 1 is 1. We're going to add our partial products, which is $18. And since it's a decimal, we're going to have to put in our decimal point 2 places. So the cost of the pencils was $18. So the cost of the notebooks was $120 and the cost of the pencils was $18. We also know that she got back $2 change. So what we can do is we can remove the $120, the $18, and the $2 from the $300. What remain would be the price of our book bag. So to remove it, we would first add all the money values together. $120, we put the point. $18 and $2. When we add them together, we get 8 and 2 is 10, 2 and 1 is 3, and the 1 is 4. And we bring our 1. So the cost of the 2 items and the addition of the change is going to bring it to $140. We are now going to remove the $140 from the $300. 300 take away 140 0 0 0 10 take away 4 is 6, 2 take away 1 is 1. So $160 would have been the cost of the book bag. So we can write cost of book bag is $160. And now we look at our third problem. Our third problem comes from the shop. And it says, and I read it, and you can follow at home. A shop had 120 bottles of water left after selling 23 cases of water. If one case holds 24 bottles of water, how many bottles of water did the shop have at first? Now let's try to understand the context. Now many times we buy objects that come in boxes and that are in cases. So we know that the shop had 120 bottles of water left. So we're going to write that first thing down. We know that. 120 bottles left. We know also that the shop sold 23 cases of water. It sold 23 cases. We also know that one case holds 24 bottles of water. One case holds 24 bottles. This 120 bottles are still at the shop. These cases, each of which has 24 bottles, left the shop. And we want to find out how much they had at first. So what we're going to do is we want to find out how many bottles left the shop. We know one case is 24 bottles. We know it's 23 cases. So we can write a number sentence. So we are going to write our number sentence to find out how many bottles of water were sold. 23 multiplied by 24. Four threes are 12. 4 twos are 8. And 1 is 9. We are multiplying by 2 tens. So we are going to put the 0 here for the ones. 2 threes are 6. 2 twos are 4. Now we are going to add our partial products. 2, 9 and 6 is 15. And 4 and 1 is 5. So, had 552 bottles. We also know that they had 120 bottles left at the store. So together with what they sold and the 120 that is left, we can put it together by adding them. So 2 and 0 is 2, 5 and 2 is 7, and 5 and 1 is 6. So the store had 672 bottles of water at first. The store had 672 bottles of water. That's the end of our third problem. Welcome back. We are going to go on to problem number 4. And on this problem, we have a table. So as I read this problem, and you will read yours at home. The table below shows the number of coins 3 students saved in a month. The 3 students are Javan, Sean, and Mali. Here we have the number of coins. Javan saved 134 coins, but the coins were 10-cent coins. So he saved 134 10-cent coins. While Sean saved 200 5-cent coins. Marley, on the other hand, saved 48 25-cent coins. The question we are asking is, what is the difference between the largest and the smallest amount of money saved? What do we know? We know that we have 3 children. One saved 134 10-cent coins. So I'm going to write this over here. Javan saved 134 10-cent coins. We have Sean. Sean saved 225-cent coins. That's what we know. We also know that Marley saved 48 25-cent coins. Cent coins. Now, for us to do what we want to find out is what is the difference between the smallest and the largest amount of money saved. So, to find out the amount of money, we have to apply our unitary method again. 134 10-cent coins. So we have to multiply 134 multiplied by 10. And we can use our mental math strategy. When we multiply a number by 10, we just add 0. So we have 1,340 cents. 1,340 cents. Finding out for Sean. Sean saved 200 multiplied by 5. And we can also use our mental math strategy. 200 multiplied by 5 is 1,000. Finally, we have Marley, who saved 48 25-cent coins. 48 multiplied by 25. Our mental math strategy for 48 multiplied by 25. Whenever we are multiplying by 25, we add 2 zeros, which will bring it to 4,800. And we know that we have 4 25s in 100, so we can multiply 4,800 and then divide it by 4. So we'll do that one right here. 48, and we divide it by 4. And we know that 48 divided by 4 is 12. 1,200 cents. 1,200 cents. This 1,000 is also 1,000 cents. Now we want to change these cents to dollars and cents. So we are dividing it by, we are going to move our point 2 places to the right. So the 1,340 cents becomes $13.40. The 10,000 cents becomes $10. And the 1,200 cents become $12. The question asks that we find the difference between the largest and the smallest. So the largest is $13.40 and the smallest is $10. So we are going to subtract $10 from $13.40. Answer is $3.40. $3.40 is the difference. So we can write $3.40 is the difference. And that's the solution for problem number 4. We are at problem number 5, and this problem introduces a raise, but it's introducing it in the form of chairs in a hallway. So as I read the problem, I want you to read along at home. Chairs are arranged in equal rows in a school hall. Mark is sitting in the middle row with 13 chairs on either side of him and 7 rows in front of him. If there are 145 persons sitting in the hall, how many seats are empty? And I'm going to read it again. Chairs are arranged in equal rows in a school hall. Mark is sitting in the middle row with 13 chairs on either side of him and 7 rows in front of him. If there are 145 persons sitting in the hall, how many seats are empty? We know that the chairs are arranged in equal rows. So I'm going to write equal rows here to remind us of that. Equal rows. Mark is sitting in the middle row. So Mark is sitting, let's say, put this right here for Mark. Mark is sitting there, and he has 13 chairs on either side of him. So we'll put a stroke for a chair. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. On either side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is Mark's chair. And there are 13 chairs on this side and 13 chairs on that side. The problem also says that he is sitting in the middle row. So that means there are going to be chairs this way and there are going to be chairs that way. And the problem went on to say there are 7 rows in front of him. So that's 1, 2, 3, 4, 5, 6, 7. It means there are also 7 rows behind him. 1, 2, 3, 4, 5, 6, 7. So from this drawing, we can know how many rows there are and how many chairs in each row. So we have 7, so we'll put 7 here, and the 7 here, and then this one here is 1. So 7 add 7 add 1 is equal to 15. So there are 15 rows. But we also need to find out the number of chairs in each row. They said they are equal rows. So if this is 13 and this is 13, then this is 1. So that means that we have 13 plus 13 plus 1, and we know 13 by 2 is 26 and 1 is 27. So we have 27 chairs and 15 rows. What do we have to find out? We have to find out how many seats are empty. But what else were we told? We were told that there are 145 persons sitting in the hall. We have to remember, since Mark is a person, Mark is one of the 145 persons. So if we find out the number of chairs in all, then we are one step closer to finding out how many empty chairs there are. To find out how many chairs in all, we have to come up with a number sentence. We know the number of chairs in each row, which is 27. That's the unit. And we know the number of rows, which is 15. So our number sentence would be 27 multiplied by 15. 5 sevens are 35. 5 twos 10. And 3 is 13. We're multiplying by the 10. So remember to put in our 0 and our 1s. And we have, and in our identity property, we know that any number multiplied by 1 is the same number. So we can put down the 7 and the 2. So 5, 0, 4. 405 chairs in the hall. And since there are 145 persons sitting, it means that in order for us to find out how many seats are empty, we're going to have to do a subtraction. So 405 take away 145, 0. 10 take away 4 is 6. And 3 take away 1 is 2. 260 seats are empty. So we can write in there, this there, 260 seats are empty. That's the solution to problem number 5. In this problem, we use the strategy, draw a diagram, and it helps us in our solution. This is problem number 6. And this problem is about sports. As I read this problem, you can read it at home. Dana entered a netball shooting competition. There were 24 shots to the net. 5 points were awarded for each successful shot, and 2 points were deducted each time she missed a shot. If Dana scored a total of 57 points, how many shots did she make? I'm going to read it over again. You can read it over at home. Dana entered a netball shooting competition. There were 24 shots to the net. 5 points were awarded for each successful shot, and 2 points were deducted each time she missed a shot. If Dana scored a total of 57 points, how many shots did she make? Now, what do we know? We know that from out of the 24 shots, each time she was successful, she got 5 points. Each time she missed, she lost 2 points. We also know that she scored a total of 57 points. And what we want to find out is how many shots she made. So we are going to write what we know. We know that a shot is 5 points. And we know that a miss is 2 points less. So the strategy that we are going to use to solve this problem is the guess and check strategy. But in order for us to do that, I'm going to put it in a table. So the table, the headings for the table is going to be shots, misses. We're going to do some calculations. And then we are going to have the points. So we are going to take our first guess. We are going to guess that she made 24 shots. So you'll put 24. And if she made 24 shots, then it meant she had no misses. So we're going to calculate 24 multiplied by the 5 points per shot. That is equal to 120 points. And 0 misses multiplied by 2. With the 0 property, it's 0. So 120 subtract 0 is equal to 120. So it meant that she would have scored 120 points. But that's not what she scored. She scored 57. So this first guess is wrong. So we're going to try 23. So if she made 23 shots, it meant that she would have missed 1. And 23 multiplied by 5 is going to give us 115 points. It meant also that she would have missed 1. So that would be 1 multiplied by the 2 points, which will be 2 points. But since this is 2 points less, we'll have to subtract it. So 115 subtract 2 will be 113. So it meant that her points would be 113. But her points is not 113. It's 57. So we're going to try, so this is wrong. We are going to try 22. So it meant that she would have scored 22 shots. And if she scored 22 shots, she would have missed 2. So we're going to multiply 22, multiply by 5, and that will be 110. And to find out how much points less, it would be 2 multiplied by 2, and that would be 4. But as we look at this, we recognize that 110 take away 4 is 106. So her points would be 106. And she did not make 106 points. So, but looking at it, we recognize that we have patterns. Because at 24, she was 120 points. She lost none, so she gets full points. She would have gotten full points if she had scored 24. And then when one shot was missed, she lost 5 points, and she lost another 2 points. So that would have been 7 points. 7 points. And we also notice between 120 and 113 is a loss of 7 points. We also notice that between 113 and 106 is another loss of 7 points. So it means that each time she missed, she lost 7 points. So then we can use that pattern to help us to solve it quicker. If she scored 57 points, it meant that she would have lost a certain number of points. And that certain number of points would have been in degrees of 7. So we can find out how many points she lost from the total amount of points, which is 120. From 120, we can subtract the 57 points that she made, and that is going to give us 3, and 5 from 11 is 6. So she would have lost 63 points. And if she lost the 63 points, if we simple multiplication facts, we know that 63 is made up of 9 multiplied by 7 is 63. So it meant that she would have lost 9 shots. Out of the 24 shots, when I remove 9, it's going to give me 15. So she would have scored 15 shots. But we're not going to stop there. We're going to check to see if we are correct. 15 multiplied by 5, 5 5s are 25, 5 1s are 5 and 1 and 2 is 7. So she would have scored 75 for shooting 15 shots. But it meant that she would have missed 9 shots. So that would have been 9 multiplied by 2 would have been 18. So she would have lost 18 points. So 75 subtract 18 7 and 5, 57 points. So we are correct. So then the question is, how many shots did she make? She made 15 shots. So in this problem, the strategies that we use were guess and check, use a table, and use a pattern. So you can use either one strategy in solving your problem, or you can use a combination of more than one.